Hi, welcome to Raw Math. Today I'm doing a series of videos on rational expressions and rational equations. Rational means fraction, and in this case it's a combination of polynomials and fractions. My first concept that I want to deal with in this video is the idea of when you have a final answer, a final fraction, writing the domain and reducing, because we all know that every fraction needs to be reduced. Now, fractions are division that haven't been divided out yet. So the 3y minus 6 and the 3y minus 6 numerator and denominator, they can't cancel because in the denominator it's actually 12 more. You can't divide things that have addition or subtraction that haven't been factored. It can be addition and subtraction in the parentheses, not outside. If I had 5 divided by 5 plus 12, it's not reducible. It's 5 over 17. You have to factor first. And in this case, we actually have to multiply, then factor. So if I just spend a little bit of time looking just at my denominator, that's where I'm going to start. I could keep everything in the fraction, but that ends up being a lot of written work that doesn't really need to be written. I'm going to distribute the 9. So I'm going to have 27y minus 54 plus 12. I'm going to combine my like terms. 27y minus 42. All right, so the last thing I need to do is factor, but at this point I can bring back my entire fraction. I've simplified the denominator up to the point of factoring. The numerator has a 3 that can come out, so does the denominator. So when I go back to the fraction, I'm going to have 3 times y minus 2 divided by 3 times 9y minus 14. So the 3's cancel. And when I say cancel, I mean 3 divided by 3 is 1. They're inverse operators of each other. So we reduce this by having them equal 1. Saying cancel is just a shortcut of terminology. I don't reduce before I do the domain. The reason is if there was a y minus 2 in the denominator, that has to be represented in the domain. If you can cancel out a 0 from the denominator, that becomes a hole in your graph, and if you can't, that becomes an asymptote. So to find my domain, I say 9y minus 14 cannot equal 0, which means 9y cannot equal 14, or my domain is y cannot equal 14 over 9. Now, this is how I like to write my domain. It's not the only way. Some people write all real values of y except 14 over 9. That works as well. Some people shift from inequality form to set notation. And if we were going to do set notation, we would end up writing negative infinity to 14 ninths joined with 14 ninths to infinity. But I am not going to be focusing so much on set notation in my videos. Now that I have my domain, I reduce. And to reduce, I divide 3 by 3, get 1. It's good to write the 1 because if everything cancels, I often have students write 0. But 0 is the addition identity, not the multiplicative identity. We go to 1 through multiplication and division. We end up with y minus 2 divided by 9y minus 14. Now, I don't need to add these parentheses at the end because there's nothing outside of the parentheses. I like the parentheses because it reminds me that the numerator isn't 2 different numbers, it's 1 number. It's a number that's 2 less than y. The y and the 9y can't cancel because it's not just y, it's 2 less. It's not just 9y, it's 14 less. You have to factor first. Okay, for my second example, I'm going to, just like I said, I'm going to factor that denominator first, and it's going to factor out to be x plus 3 times x minus 2. I have a bunch of videos on how to factor trinomials if you are uncertain, but basically because what's multiplied to the x is 1, we find 2 numbers that multiply to negative 6 add up to positive 1. So my domain becomes x cannot equal negative 3 because negative 3 plus 3 is 0, and that's what our domain is really telling us. A fraction has a restriction that the domain cannot be 0, so we find the zeros of the domain by solving it and say, hey, those are our restricted values. X cannot be negative 3 or 2. Now, I will just quickly put for set notation, in case you do need to understand set notation with two values, set notation would say negative infinity to negative 3, joined with negative 3 to 2, joined with 2 to positive infinity. I want you to note, joined with union. Everything is parentheses because it cannot equal the negative 3, it cannot equal the 2, so we don't use brackets, we just use parentheses. Okay, now to reduce. Let's look at our numerator. And I'm just going to focus on the numerator now because the denominator is factored. And the denominator was pretty simple because the number multiplied to x squared was 1. In the numerator, it's 5. So I'm going to do the AC. And the AC is where you multiply your extremes. 5 times negative 6 is negative 30. And find two numbers that multiply to negative 30 and add up to 13. So the heart of it's the same, but we just need to bring that 5 in. So this is going to end up being a positive 15 and a negative 2. You have to be really careful because if this was a positive 30, it would be 3 and 10. Your head goes to 3 and 10 for 13 really quickly, but this negative means we're going to have to get there through subtraction because the 2 need to multiply to a negative. Now, there's a really cool fraction technique, which you can see on my other videos. I'm going to stick with AC for now. 5x squared plus 15x minus 2x minus 6. I just replaced this 13 with the two numbers that add up to 13. I can take a 5x out of the first two terms and a negative 2 out of the second. 5x times x plus 3 minus 2 times x plus 3. So my new fraction becomes x plus 3 times 5x minus 2. My denominator, we already factored, is x plus 3 times x minus 2. Now, when we get to this point, we notice that the x plus 3's cancel, so that my reduced fraction is 5x minus 2 divided by x minus 2. I have to add that 3 in, which is why we did our domain first. Add the 3 into the domain part. Also, I have a lot of students who want to pretend that the 5 is outside the parentheses and the x minus 2's cancel. They don't. This is 5x minus 2, not x minus 2. So this will become my final answer. I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks!